Hi, we're going to talk about stress, okay? So basically, there's three types of stress, okay? There is stress as a stimulus. So these stimuli are called stressors. Makes sense, okay? They can be external, for example, noise and temperature, or they can be internal, for example, pain, okay? So then if we look at stress as a response, okay, it is how your body reacts to these stressors, okay? So it's the physiological effects that come about because of being within the vicinity of these stressors, okay? And then if you look at stress as a transaction, and that is the way that the medical staff see stress, we can say. It's a balance between what is demanded of you and what you can cope with, okay? So just to reiterate, three different types of stress. The first one is the stressor. Stress is a stimuli. The second one is stress as a response to this stimuli. And the third one is stress as a transaction. And that's the balance between what is demanded from you and what you can actually give. Okay? So the third one, just to explain it a bit better, that's more like we can say how well you cope with it. So I don't want to spend too long on this, but basically, something that causes you stress, what you're going to do about it, how well that works, okay? So Hans Selye devised that there was 3 ways to cope with stress, okay? And 3 ways that are kind of consecutive, okay? So first of all, there's the alarm reaction. Then there's the resistance stage, and then there's the exhaustion stage. Okay, I hope none of you go through any of that. So with the alarm reaction, that tends to be short, okay? This is the first part, okay, the alarm reaction. So yeah, again, that tends to be short. The stress is a stimulus, such as, like we said, injury, danger, hemorrhage, okay? That's sensed by the limbic system, okay? So, just to reiterate, okay, this may get annoying, sorry. The limbic system senses the stress, okay? And then when it recognizes this danger or stress, it sends a message to the cerebral cortex, okay? So let's imagine this like a flow chart, okay? So, stress is a stimulus, okay? Sensed by the limbic system, which in recognizing the danger or stress sends a message to the cerebral cortex, okay? The cerebral cortex, then sends a message to the hypothalamus, which is all up in here, okay? And then the autonomic nervous system takes charge, okay? So just checking you have all this, yeah? Short, alarm reaction is short. Stress is a stimulus, sensed by the limbic system. And then when it recognizes that danger or stress, sends a message to the cerebral cortex. Okay, that then sends a message to the hypothalamus. That then causes the autonomic nervous system to take charge. Okay? So then, this causes the sympathetic nervous system to intervene, okay? And when the sympathetic nervous system intervenes, okay, it acts on the adrenal gland, okay? And we can look at the adrenal gland in 2 ways, okay? The first way, not really sure which path to take. Okay, let's go with this one. The first way is the adrenal medulla, okay? And the adrenal medulla can secrete adrenaline and noradrenaline, okay? And it can secrete catecholamines, okay? Which is spelled catecholamines, okay? So the adrenal medulla, okay, from the adrenal gland, can secrete adrenaline and noradrenaline, and it can secrete catecholamines, okay? The catecholamines, what do? Okay, basically, they cause increased metabolism, okay? They cause increased water retention. They promote peripheral vasoconstriction. they increase heart rate, and they increase blood pressure. Okay? So that's what the catecholamines do. So the catecholamines and the adrenaline and noradrenaline all come from the adrenal medulla, and they act on the bodily tissues. Okay? What also acts on the bodily tissues is the adrenal cortex when it secretes cortisol. Okay? Just a random fact, the adrenal cortex shrinks even though most of the hormones arise from the adrenal medulla. Weird. Anyways, cortisol increases glucose levels and can cause temporary stage of diabetes. Okay? Diabetes, a whole nother lecture. Alright, okay, so we have cortisol from the adrenal cortex, adrenaline and noradrenaline, and catecholamines. All of these acting on bodily tissues. Okay, what do these cause? I'll tell you what they cause. They cause the fight or flight response. Okay, remember that, the fight or flight. Whew. And so this includes the mentioned catecholamine response that we said, with the metabolism, water retention, blah 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 blah. And you get better hearing and vision, amazing. You get slower digestion because the glucose is reserved for and shunted to muscles, the eyes, the sensory organs, the brain. So basically, it's kind of where you don't need it as much is kind of like moved away from there, and it's shot to the areas that, would help you with this fight or flight response. You have an increased sweat. I'm sorry, that's not grammatically correct. But yeah, you increase your sweat production, okay? You release endorphins, which increase your pain threshold, okay? Quite interesting, really. Glycogenolysis occurs, where the liver releases glucose and fats for energy. Your pupils dilate, okay? And then visceral effectors can cause bone, and the visceral effectors are like your bone, which can cause increased blood cell production, your spleen, which can release the stored blood, your lungs, which have increased ventilation and dilated bronchi, and the blood clots faster, okay? So, just a random fact about the alarm reaction, it can cause ulcers to develop depending on how long it lasts, but it should only be quite a short phase. The lymphatic and thymus glands will enlarge,